started recording. Okay, let's get started. Hi everybody. Thank you so much for joining. Good evening. So this is the first vodka shot. Usually we used to have it in the weekdays, probably 3 hours or 4 hours long. And earlier, before the pandemic situation, it used to be offline. So we wanted to change it so that there could be more participation, because we understand that it might be not easy for all of us to join in the weekends. And also we firstly want to thank you for joining during the weekdays. There are people who could have meetings in the evening, but thanks for taking time. We hope that you would learn something by the end of the session. So yeah, myself, I am Subha Dhanashekhar. I've joined ThoughtWorks a couple of months ago, and I have around 5+ years of experience in QA. I've been working in different domains, and primarily insurance, and right now I'm working in e-commerce domain. And primarily I was working in automation testing and front-end testing. So that's about it. And recently I've started learning all the other tech stacks after joining ThoughtWorks. It's been quite a journey. So this is the first ORCA that I am organizing, so I'm looking forward to it. And okay, I firstly about ORCA. ORCA is nothing but value-oriented discussion for the QAs. So for the quality analysis, and this forum is created in such a way so that we can all the QA community can come together and learn something new. And this is a unique platform which is not only constrained for thought workers, it's for the QA community. That is the reason why we have kept the registration open, and anybody from the QA community, or anybody who's not from the QA but who is interested to learn about the QA can join. So we generally try to discuss the latest and the emerging technologies, or something unique which is running in the software testing industry, so that our community can strengthen through this knowledge sharing. So that's about ODCA. And yeah, over to you, Arun.
Yeah, thanks for giving the warm update. So myself, Arun Kumar. So I have been with ThoughtWorks for past 2 years, and my overall experience is 5+. And I work as a quality analyst in the ThoughtWorks, and my technical expertise is manual testing and automation. Yeah. So this was my short intro about it, and yeah, moving to that, we can get started. We have a keynote update. Actually, Nanda Kumar is from ThoughtWorks. He's going to give about the keynote about the whole event and for this vodka event. So as he was not available, so he has recorded his session. Actually, we will be playing over here now. So to give a quick short update about the this event, Namda Kumar is from ThoughtWorks, and he has been 15 years of experience in ThoughtWorks, and he's a project manager right now. So his experience includes he's from the QA background who transitioned made to project manager now. So this is a short intro about him. I will just share my screen and will play the video recording of Nanda Kumar. So
Yeah, we would also like to thank Nandakumar for, like, although he got some personal work at the last moment, he wanted to keep the show running, so he was kind enough to send the recording to us so that it wouldn't get affected. Thank you, Nanda, for that. I'm sure you would be watching this recording after we post it in the forums. So yeah, Arun, we can share.
Hello all, welcome to another amazing event of vodka. Wish we could actually have this in office event where you could actually connect with more people, seeing face to face, and build social networking and social connects. To introduce about myself, I'm Ramda. I'm with ThoughtWorks for 10 years now, and I have a QA experience of 15 years, currently managing a financial project with ThoughtWorks. In the past 10 to 15 years, there had been a paradigm shift in the way QA's roles, responsibilities, the tools they use, the automation technique, the strategies, as I think completely changed a lot. In fact, right from the staffing rate or hiring for QAs or for a project was just at the time of the start of the project, but now they are actually participating in requirement gathering workshop or Inception Workshop, where application development requirement is being discussed. Since they are in the Inception Workshop, they are able to actually discuss about the non-functional requirement, what you call as the NFR, at the inception stage itself or requirement gathering stage itself, where they talk about performance, right? What is the response time needed? What is the number of load that you actually expect as part of a system? And if it's a mobile device, right, what are the different OSs we need to support, compatibility, and all those questions, right, which will actually mostly will come as part of your UAT phase or production prod phase, right? As it's being discussed at a requirement gathering phase. So all this information are taken and systems are designed or architecture based on this, and your release plans and stories and estimates are taken into consideration. These requirements that comes out of QA expertise. Having good understanding of architecture, system architecture, and how the data flows will actually help us in understanding the system much better. I would like to give an example, right? In one of our projects, what we are doing was we are actually building an API. We had a front end, we had an API layer, and then our API was APIing a third-party system. And we were doing some performance testing similar in the product performance in testing environment, PT environment, where the infrastructure is similar to the production. We were ramping up the load for close to 10,000 users, and the response time were very good. So, but once we put the system in production, we saw a tremendous drop in the response time. And then that's when we understand that it's not only our system which is actually interacting with the third-party system, rather a set of other systems are also actually using the system, and close to 5,000 users are actually using that, and significant, almost like 50% of the load was also coming from the other system. And then we went on asking for a little more hardware for the third-party system, and then it was actually the performance was the issue was solved. This could have been very well understood if you could have understand the whole enterprise architecture, right? And asking those relevant questions could have actually solved this problem from start itself. One more example I like to quote is a predictive caching kind of a thing which we are doing for you're like a valet or a gift card balance kind of a pay. So this information, right, the balance and the credit and the gift card details was actually coming from a different third-party system, and it's the performance was very poor. So what we did is, right, once the user logs in and actually sees the dashboard page, even before clicking the gift card section, we'll actually make a call to the gift card section and actually store it in the Redis. So this was how we actually have designed the architecture, and so by then, right, so once the user clicks on the gift card page, we will actually get the details from the Redis cache itself. So we tested this journey multiple times and did a performance testing, and we are happy with the response time by this, because we are not able to solve the third-party system which was actually giving this gift card details, right, balance and other details. But what happened in production is they were actually sending some kind of offers or notification where notification links where users could actually directly add money using that link. What that link is, right? As you click on that link, it will take you to the login page where you can actually enter your username, password, and it will directly take you to the your gift card page. Okay, so your predictive caching didn't happen, right? I think this was very surprising to us, and we are actually we didn't actually miss that flow, is what I would say, right? And then what we did is actually we moved that predictive model caching from dashboard page to a end of a login page, right? That itself we started caching to improve the gift card page, right? So you need to understand how the data flows, what could be the data flow, and work on that. You would have heard of shift left strategy, right? Where I think anything that you do as what is that, testing or automation, right? Shift left and see if you could actually start it, ask those questions early in the project. Same way that something called a shift right, I would say, is meeting your in customers, right? I think, or the real broad users, having some kind of a discussion with them in understanding how they plan to use it, if it's a new application or if an existing application, if you are revamping it, try to actually spend some time with them and understand how they actually use the system. That will give you a lot of insight on what to actually build or what to test or what is the important thing aspect, right? Those what to say, those feedbacks you could actually get a little early. I just like to an example, one of our example, right? So we were actually building a handheld device for what to say, a clothing store, replenishing an order, and it was built in Windows CE, Palm OS kind, or Windows OS kind handheld device. So what they do is, right, the store executive will actually scan the tags and see, right, if a particular size quantity is less, they will actually order it from their central store, where they will actually come and do the order replenishment. So there are stylus available, and we tested most of these things via stylus and a few things via the hand. But once we actually walked into the store and see how the executive users, right, they never use stylus at all. They always use the hand. Reason being, I think many of the people, right, they don't even have the stylus, or it's lost. Right? And one difficulty they were actually facing is the scroll bar. Right? If you use stylus, right, it's like a very small scroll bar we are given, but they were actually using the hand. And so we actually learned from that, and then we increased the width of the scroll bar, and they were able to easily scroll using their fingers. And we also had a checkbox for individual sizes, right? For example, small, medium, large checkbox, right? What needs to be ordered. But when you actually use your hand fingers, it will actually select multiple things, right? So the fingers were huge, so we actually saw that, and then we actually gave a lot of space for that from one size to another. And this did a lot of UI changes after how they actually use in the store. So it's always good, right? Actually go have kind of working session with your real users, or at least sit and one day observe how they actually use the system. Right? I mean, it may not be the way you actually think through, but their journeys and their things will be completely different. Okay. Thank you all, and wishing all the speakers and organizers and participants very good work. Thank you.
So virtual thanks to Nanda Kumar. And so yeah, before we start with the topics, we would like to say that apart from vodka, ThoughtWorks also organize different events like this. For example, for devs we have the geek nights, and for BAs we have Converge, and it's all open for all of us. So right now I am going to share a couple of links, the meetup links and ThoughtWorks website, so you can follow us. And going forward, if you are interested to speak, or if you are interested to follow up on the upcoming events that ThoughtWorks is organizing, you can definitely keep an eye on it. So over
Yeah. So yeah, we can get started. Just giving in short intro about Narmadha and Sameena. They are going to present the topic of functional programming in testing. So both of us from the ThoughtWorks, and they are having a vast experience in the QA background. So yeah, over to you, Narmadha and Sameena. We can get started.
Yeah. Thank you, Arun. Thank you, Subha. Let me just share my screen.
And if you have any doubts or any concerns, there is a QA option. You can drop your answers. It would be answered, and also you can feel free to raise your hand anytime. Thank you. Thank you, Namita.
Yeah. So today we're going to talk about functional programming and testing. So this is most of the people don't follow functional programming, at least in testing. So we thought when we are coming across this, we'll try to share what learnings we had. A little, if I have to talk about how we decided to talk about this, it's like we both of us, me and Sameena, we were from the OOPS oriented background. So most of our coding patterns, we followed different frameworks, and all of that we try to use object oriented style of coding, right? And then we came across a project where the source code was all written in functional programming style. And the reason is it had a lot of computational functions. And then when we started exploring functional programming for that, we found it more useful. I mean, we found a lot of different concepts and new concepts. So this is purely a informative session where we'll share our learnings, and we hope all of you will have some takeaway from this. So for the ease of understanding, I'll start with a simple use case. Okay. So let's say I have a retail client, and one of his module is say return items. Say the business use case says the user can return his item at different outlets. Okay. So the business use case is going to be like a user can log in. He can select the items from his order, and he can choose the store where he wants to return his product. And say he also has to key in his return dates, and he has to submit this. Okay. This is say one simple one use case. This is say one module. But the where the complexity kind of starts increasing is, say this is the one client, but he has multiple platforms, and he's going to use the same we're going to use one product, right? We're going to have the backend and the APIs for one product, and we're going to leverage it for different platforms. So when I say that, let's say for example, let's say my client is Reliance, right? So Reliance, say it has its Reliance Smart, it has Reliance Digital, and it has Reliance Apparels, right? So when but I want to give the same return system for all the three websites. Okay. So when you have such a use case, how do you go about automating such scenarios? Okay. So even in this use case, let's further split it down. Let's just say on the return page, we're just automating the store functionality, the user selecting the store functionality. Now, like I said, the base product is going to be the same. So, but we're going to leverage it for three different websites. And let's say we're following the test pyramid, right? We're going to have the relevant tests at relevant stages. We're going to have unit tests. We're going to have integration and all of that. But now when it comes to UI, I want to say use one automation test, which is going to run on all three units, right? Which needs to test this functionality. So what would be the complexities, like what would we need to ideally handle, right? So say each guy, let's say for the store itself, right? Each of the outlet is going to have different data. So if a simple get store API, say it will give you 20 items for my Reliance Smart, it's going to give me 3 items for clothing, and it's going to have 30 for digital. And let's say all these three are three different clients, okay? But the base product is same, it's just Reliance, right? So the client is going to say, I need a different kind of configuration. Okay. Or to display the select store on the UI also, each one wants to have his own configuration, and that is allowed, right? We can easily develop that. So say Mart is saying, allow me to select the store from a drop down. Clothing is saying, I'll have only my 3 biggest outlets, and they have to choose one of the outlet and they have to process return for that. Well, digital says, I'm happy to get the return product. Uh, Return it at multiple stores also is fine for me. So the functionality is the same. You have to select the store, but what it does is different things, right? How you have to do it is different. So if we ideally go with the normal general automation approach, how we would do it, if we just look at that, let me just take you through a little bit of code. So for the sake of comparison, right, we've chosen JavaScript so that you get a clear comparison of how the code looks like in object-oriented approach and a function programming style approach. So let's say just the get store API, right? If you just want to test that, you would ideally test it for, say, an invalid store, and you would test it for a valid store. Okay. Now, since I said the stores which is going to be returned is going to change, it's not going to be the same store IDs for each client. So you always have to send a store ID after getting the store ID, right? Like you have to first hit an API which returns all the stores which is present for that platform, and then you will try to send and then you'll try to validate if that store is present, right? So you have to keep your tests a little data independent. You can't keep using the same data for all the tests, and only then this is going to test your get stores API a little more. It's going to test it strongly, importantly, in your in across clients, right? Now the same thing if I want to do it on the UI. What I would do is, let's say for simplicity, I'll just have like, I'll take the data from like, I'll have different client files. I'll take some base amount of basic data. So this client data method, let's say it can be anything. You either fetch it from DB, you fetch it from config files, or you fetch it from your application storage. Any way you fetch it, okay? You have data for the client. And then to select a store, right, I'm telling you that the display field is going to be different. Okay, so when you want to get the web locators, it's all going to be different for each client. Since the locator is going to be different, you'll need to get the field name, at least whatever is configured, which is going to be constant for each client. Based on the field name, you're going to you're going to get what type of a field it is, and then based on that you're going to go and select the stores. Okay, for this you'll at least requires these many methods, is these many steps, I think. So let's say you first get all the store names, then you try to get what type of a field it is, what you try to get the element, then you try to say how many stores for this client we need to select, right? If it's a multi-select option, I need the list of the stores names. Okay, we have another function to do that. And then you're finally going and selecting the options from the drop down. And then whatever is selected in the drop down, you're just trying to validate if both the names are same. This would be one way of coding. And of course, you'll put it in your base methods, and you would use inheritance and abstraction and all such concepts to achieve such things. But if you look at it at a larger point of view, right? So if it's one small functionality like get stores, maybe that would work. Okay, but once you start writing in this approach for a vast use case, like this is just to get store, you write so much, and then you select items. For that you need more logic, and again you need to select date and such things. So when you cover an entire UI flow, what was happening is our test case was getting very tedious. we were kind of repeating functions. We were sending the same arguments to multiple methods again and again. Okay. So there might be different approaches to solve this, but we'll just talk about how we solved it with how we implemented this in functional programming style, right? So before we look at the code for FP, we'll just walk you through some concepts so that you will find it relevant, like you'll be able to understand how the code flow works. So over to you, Sameena. Sameena, you're on mute.
Okay, thank you so much, Narmadha. Yeah, so in this session, after this, once we get through the basics of functional programming, we'll see the code walkthrough of comparison between FP and non-FP. And to do that, we should understand the functional concepts, right? Just understand what is functional programming, and then we'll see a few basics of functional programming with the examples, and then we'll go to the code walkthrough. So to understand what is functional programming is again a coding style where you'll be having extensively working with the pure functions, which is nothing but you'll be writing your code in small chunks of functions. Even if it is a single liner, we'll make it as a function. Arrow functions we'll call it as arrow functions in JavaScript, and we'll start using the functions extensively in your code. And the motto behind the functional programming, it focuses more on what you want to achieve. What is your end goal instead of how you're gonna achieve. But when you compare with the descriptive languages, right, like Java and all, we have to define in the descriptive way. We are not focusing on the end goal. We have to define to reach that end goal what we have to do. But in functional programming, you will see little difference. Like you're gonna target towards your end goal first, then how you're gonna do it, right? You will understand once we learn few concepts about it, then you will be very clear. Now you can see in this example, we have a function called adding numbers, which will take 2 parameters. And just we are returning sum of those 2 numbers, right? And in the functional programming, the crux of functional programming is like treating the functions as a values. You are treating functions as your data, like how you will manipulate with the data and all. That's how we are using as a functions in your functional programming. Now you can see the adding numbers, I'm going to assign to my constant, which is nothing but sum. Okay, I can use that sum by providing the parameters, so it will go and execute my function. So if I just go and print my sum, it will return me the function as is, like how you are accessing variables, right? The similar way, if you're just accessing the constant sum, it will just return you the whatever you have written in the function, just returns a function. It will not execute it. But if you're assigning a constant and if you're providing the parameters required for it with the parentheses or any parameters are required for it, like right now we define it as x and y. If you're calling sum of 4, 5, then it will go and execute. And if you say just console.log, it will just give you the function. This is how you can see the difference between your descriptive and the functional languages, right? You have the like you have the crux of it, like you can make use of functions as arguments and return the functions as in from other functions. All these are the basic concepts of functional programming. Yeah, we can let's see the benefits of functional programming in testing frameworks, right? Why we should use FP in testing frameworks wherever it is possible. So let's say the benefits of it is like parallelizable. Like why we are saying parallelizable, like we are doing with the pure functions, meaning it is an independent code which you can run in parallel, right? It's a small chunks of code for you. We are defining functions. Everything is independent and pure functions. Mostly wherever it is possible, we're gonna do it in parallel. So it will be more parallelizable than your descriptive languages. If you take an example of loops, right? In loops, we'll be having one driving function which will decide your starting point and the ending point. It will be in sequence, right? You can't go one before and one after, right? But if it is an independent pieces of code, it can be parallelizable easily. That's how we can achieve the parallelization in FP. And reusable. Again, if you are writing your code in small chunks of functions, which can be reused whenever you want, and it is more modularity, it will give you the benefit of clean code, right? And then composable. What does it mean, composable? It is like you will be having the how you can stitch your functions together. And if it is independent functions, you will be having that benefit of stitching together and get one output out of it. Multiple functions together and then get your out of it, right? And FPs are mostly suitable for complex systems where you have vast data. There is no shared data between your systems. And if you want to have multiple calculations and algebraic calculations, if you have, In those cases, you will go with the FP.
Sorry to interrupt.
Yeah.
Can you go a bit slower? Actually, one of the participant was not able to follow up on the speed.
Sure, sure.
If you could take it a little more slow, it would be great.
Sure, sure.
Thank you, Sameena. Sorry for interrupting.
Yeah, okay. So right now we discussed two things. We just discussed what is functional programming, right? Functional programming is the one where we'll be getting all the functions as data. Like we are treating everything as functions, and we'll be having the flexibility to treat functions as a variables. Like in the previous slide, Narmadha, can you just go previous slide so that, yeah, here you see here we have one adding numbers function which I'm assigning to a constant, which is sum, and I can make use of that sum. If I just print the sum, it's gonna print me the function as is. You can see the commented code is the output of each one, however you're gonna use. And if you're gonna use the sum with the parameters, it will execute the function for you. Okay. And here we will see why we are saying it focuses more on what rather than how. Okay. In the next slides, you will learn the concept. And the benefits of FP is parallelizable, because you are using pure functions which doesn't have any dependency on your data or state or behavior. So it is more parallelizable. Like you can execute at one shot, and it will give you the benefit of flexibility to execute in parallel. And then reusability, as its functions, right? It's to increase the modularity of your functions. Then composable is again how you're gonna stitch your functions together. So it will yield you one output out of all those functions, and get one output and get your end goal to be achieved. And FP is more suitable in the complex systems. Like simply if you have a basic kind of systems, we say FP is not advisable. If you have something where you have different iterations, different objects, big objects, and if you want to iterate through those bigger objects and get something out of it, or you have something mathematical algebraic expressions you have to do rigorously on your systems, that time you will go, FP is a more suitable one to go with. Okay. Next, we'll move on to the concepts of FP. And to understand, just to have a look at any code base of which is written in the FP style, right? Functional programming style, we should know little basics about what FP programming will follow. So few among them, like the most majorly used ones are data immutability, higher order functions, currying, and the composition of your functions. So first we'll look at the data immutability. So for this session, we're gonna take JavaScript as an example, because JavaScript is the one which will give you the flexibility to write in the OOPS style also, and also in the functional way also. So it will be good to compare between both. You will get the difference between those two, right? So we have chosen JavaScript to drive this this session. So here, data immutability. What does it mean, data immutability, right? Wherever you're gonna use your data inside your frameworks, right, make it immutable as much as possible. If you're gonna have something which you're gonna do something with the data, make a copy of it and then start using it, right? So data, it is suggestible, like a principle of one of the principle of FP is make your data immutable wherever it is possible. We are not saying like 100% it should make it as immutable. Wherever it is possible, make it immutable. As a JavaScript language itself, gonna give you one flexibility, like it has a const keyword. If you're gonna use it const keyword with any variable, right, it will stop the user, like a developer, to reassign any value for it. Okay. So let's say here you can see const a equal to 10. Now I'm gonna assign 20 for it. Then compiler throws me an error saying assignment to the constant variable is not possible. Anyway, you have some support from the language, but when it comes to your data is an object, okay, instead of a variable, if your data is an object, then it is not possible. It's in the developer's hands to make the data as immutable. See here, mutation of data, how we have written the code, right? There is a product which is an array of objects. You can see price 80, name t-shirt is object 1, and price 350, name bag is object 2, and array of those is my constant array, which is product. Now here I mutated by directly accessing my product of 0, and then I have updated my price to 15. Okay. So this is not advisable to do it this way, because when you are writing the functions, right, we want the state of your function to be same. In the sense, that is not advisable. You can't make it more reusable if you are making mutation of data. Then how we can achieve the immutable data, right? Now you can see here in this slide, we have the same product, which is an array of objects, but we are using spread operator. Spread operator is nothing but, you can see updated product I have used as ... right? That is nothing but make a copy of my array for me. Same thing you can apply for the objects also. Here we have taken the example of array. Now you can mutate the updated product, because I have copy of my product, which is my original array. I'm gonna keep it as is. Now I'm gonna mutate the updated product. Okay, so this is how we can avoid the mutation. This is a little bit flexibility where you can make a copy of it instead of going and writing the full copy. Just a spread operator. If you're gonna modify in the updated product and then start using that copy of it. And there is one more method in the JavaScript itself, which is object.freeze. You can use object.freeze on your objects, so that whenever you're gonna reassign it, it will throw an error saying you assigned object.freeze on your object, right? So this is how we can achieve a little bit of mutations in your code. Okay, so let's look at the second module, which is a concept, which is a major concept in FP, which is pure functions. What is a pure function? First of all, we understand functions are there. Functions can do, it's a small chunk of code which will give you some output of it, right? So if you look at pure functions is one which will yield you the same output with the same input, and it will not change the state of any variable outside of it. It will not change the state of any variables, or let's say side effects, meaning if you are saving something in DB, that is not a pure function. If you're doing a function, if it is changing something in a file, some data, it is saving it, that is not a pure function. To define a pure function, it should have input parameters, and your output should be depending on your input parameters. For the given input parameters, the output will be always same. That's how you can make in your mind, like when you're gonna write a code, I want to make this as a pure function to achieve this goal. I'm gonna do all these things. First, check out like you have given the input parameters, and your output is depending on the input parameters or not. Okay, so here it is an example of pure function, right? Pure sum, I am taking two numbers in it, and I'm returning the sum of it. So if I call that pure sum, how many times ever I call, the output will be same because my input is same. This is how we're gonna define a pure function. Now let's see what is an impure function, right? Here in impure function, you can see I have a function, impure function. In this function, what I'm gonna do, I'm gonna mutate the any variable which is outside of my function, right? You can see any variable plus element. Whatever you're gonna call the function with, impure function, I'm gonna call with 5, which is meaning I'm gonna add 0 plus 5. Now my any variable is saving 5. And in the next time, if I call it, what it will do, again, my any variable is 5 right now. Again, if you go and call 5 plus 5, right? If I call multiple times, your output is changing. It is not depending on your input. If your input is same, your output is changing because it is depending on the state of the other variable, right? So those are the impure functions. Wherever it is possible in your code base, just try to do it as a pure functions, eradicate side effects, and see you can manipulate with the output to achieve with the input arguments, whatever you're gonna get. That's how we can achieve the pure functions. Okay. Next concept in the FP is higher order functions. What is higher order functions, right? So we have seen the functions, pure functions, impure functions, and how we'll be manipulating the functions. We can assign a variable to a function. That function you can call with the parameters. Then that function get executed. And if you call just the variable, the function only gets it gets only function, or how it will just print it. We have seen, right? Now we are moving on to the higher order functions, little like a high level of concept in FP, which is higher order functions, which is nothing but a function which takes input arguments as other function, or which returns a function in turn. A function which takes the input arguments as a function, or which returns a function, is called, we are calling those functions as higher order functions. We will use very frequently these higher order functions in FP. And JS, like JavaScript is one which we're going to talk about. JS itself has a few inbuilt higher order functions like map, filter, and reduce. And these higher order functions we will be applying on arrays. Okay, so map and the filter and reduce are the inbuilt higher order functions, meaning each filter, like a map, filter, or reduce, will take the input parameter as one of the user defined functions. Okay, so let's say example of I have an array. I want to increment each element in that array. How you will achieve it, right? So normal way, what I'll do, I'll just have my input array. I'll define one more output array, which I'm gonna save the incremental values, right? So I have a const where inc equal to function. I'm gonna write my user defined function increment. In that input parameter, what I'm gonna take is my input array. Now I'm gonna looping through my full length of my input array. I'm incrementing each element at one by one, right? I'm incrementing one by one and then saving it to my output array. This is how I'll do it if it is a normal way of coding, like a descriptive way of coding. Now let's look at making use of higher order functions, how you can achieve the same goal. See here, here I have an input array, which is 1, 2, 3 again, and I have my function, which is a single liner arrow function, single liner function. So I am not writing any return. So you can define this way. And what it does, it is taking element and then incrementing element, and that is returned to whenever you call, right? And now you have output. What you're gonna do, you're gonna call that map function on your input array. In that map function, we set it as a higher order function, and you're passing user defined function, which is nothing but increment, to your map. Okay, higher order function is nothing but a function which takes the input parameter as a function. Now that is achieved, right? Input array dot map of your user defined function, meaning I'm gonna apply my increment function on my input array, and this map will return you a new map, new array, like whatever function you're gonna call. It will transform your data with that function, whatever you have written, and then it will return you the new array. Let's say now example input array 1, 2, 3 I have. Now I call my map function using my increment function. What it does, it will take the first time 1 is taken, and my function increment function is doing 1 plus 1. It will save 2, and next time it will take 2, and it will say 2 plus 1, and it will save 3 in my output array. The similar way it will iterate throughout your input array. This is why we are calling functional programming is mainly focused on what rather than how, right? Just we define one function, we applied that map to our input array, and we are passing that function to our input array, right? So out of it, we're gonna get our 2, 3, 4. Instead of we iterating it, the like language itself is providing you the flexibility. Provide your function for me. I'll apply that function on all the data, whatever you have in your input array. Okay. Now we have the similar way map. We have filter and reduce. What filter does, as a name says, right? Filter again a higher order function, which it takes the input parameter as a user defined function. Here, my filter function for filter, what function I'm going to provide is to identify the numbers in my input array is even or not. That is a single arrow function which we have given inside our filter function, right? Meaning I'm gonna use my output like a 2, 3, 4, what we got from map array, and check out how many even numbers are there and give me the output of it. So your filter function will create one more new array which will be filtered items, like according to your user defined function. It will filter out now 2, 3, 4. Out of 2, 3, 4, 2, 4 are my even numbers. So it has created even. Const even is an array for me which is having only values, filtered values of 2, 4. Okay. Now we have one more function which is a higher order function. Again, an inbuilt function is a reduce. This is a higher order function. Again, you have to write your own user defined function to pass the parameters for that reduce function. Here, accumulate this reduce is to, the name suggests, like if you want to sum of your input array, like you have 1, 2, 3, and you want to sum of like 1 plus 2 plus 3. Instead of going and have a counter assigned to 0 and then count plus element of 1, element of 2, element of 3, I'm gonna call my reduce, which is again focus on your function. What you're gonna write here, reduce function will take your first element as your first element in your array, and the next one is accumulated. By default, it will assign to a 0 value. Okay, so your function looks like element comma accumulator and arrow function, and then what you're gonna do, sum it up, like how in the normal coding they will write, right? Count plus array of I, and then your count will change to the first one 0 plus array of I is 0 plus 1, and then 1 gets added to the 2 and 2 gets added to the 3 like that, right? In here, I'm just saying I want to do sum of it. I'm going to pass you my function, which is an accumulator. By default, it will assign to the 0. Now, each time it will iterate. Element will be 1, accumulator is 0, 1 plus 0. And now element plus accumulator, it will store. And then again, it will take that value. 0 plus 1 is 1. 1. Now the element comes as 2. 1 plus 2, 3. And 3 plus 3 is 9. Like that. It will just sum it up for you. And then it will give you the end result of it. It will reduce your input array. Right? This is how, like, in few inbuilt functions works as a higher order functions for us. Okay. Then the next major concept is currying. Right? What is currying? If you look into the functional code anywhere, right, you'll be seeing some functions called inside functions, some functions called with the parameters, some functions call it as a without parameters, and parent. There will be one nested functions where you will be having it. All those stuff, right? Those things you will be achieving it using. We'll call it as a currying. Currying is nothing but transformation of your function, which is having multiple arguments, to have 1 or 2 arguments, and return a function and pass those parameters to the other functions, or whatever remaining the parameters you have. Let's say a function is taking 1, 2, 3, 4 as arguments. Okay. Now I'll say I want to curry my function. Let's say my function is gonna use my first parameter 1, and then it's gonna return me the second function, which gonna use the second, third, 4 parameters. So meaning you're gonna transform a function which is taking, you're gonna design a function such a way, like, which is taking your input parameters, multiple input parameters, make that as to take the less parameters, which is more general parameters, which you need to apply on the end product, end goal of it. And then return a function which will have the other function, like other parameters to apply on. Okay. So let's take an example, and you will be understanding better. Let's say here add x comma y, and x plus y is returning, and how you'll call add 3 comma 5, and you assign to a variable, and then you will get your result. This is how you will do it, right? The same goal I can achieve it using currying. Okay. Here, see, I made my add x comma y to have only one parameter. I transform my function in such a way, have first parameter, and then I'm returning one more function which will take the other parameter. You can see I'm going to return function other add, which is taking y. And the end goal is same. I want to sum it up, and I'm like, here you can see 2 things. With the currying, you're already getting the functionalities like partial application and closures. What does it mean? Partial application is nothing but once you say const a equal to add of 3, I'm calling add of 3. What is the output of it? It is returning me a function. If you're just calling one function which is returning other function, here you're not received the end goal yet, but you can take the parameter, like you can make use of the first function itself, right? Then that is called partial application. Like a part of function which is a curried function, you can make use of the part of function of it. Like here you can say add a equal const a equal to add of 3, which is returning you other add function, because the body of your add x is returning other functions. The output of your a will be that other functions. That is called partial applications. Like you can make use of the functions which is a partial in your currying of it. The naming convention itself will give you the little idea about what is partial application, right? Then there is one more concept called closures. Okay, what does it mean? Say add of x, you're taking that parameter, that is your parent function, I can call, right? You're currying with the parent method, and other add is your child functions, I can call. So that add x variable, I can use it anywhere. Like if let's say I have 3 more functions in it, add x, other add 1, other add 2. But I can make use of x anywhere I want inside my functions. Okay, that is called closures. Like you can make use of the first parameters or whatever parameters you have inside till that scope of the variable will exist till that function ends inside your inside your functions. Till the scope of that function ends, you can make use of those parameters, which reduces like redundant parameters what you want to pass, right? Like that. So now we'll just go back to the previous slide. So now what did I do? Const a equal to add of 3, where you just did a partial application of your curried function. Now again, I'm going to use a const b. I'm going to do a of 5. Now it remembers like add of 3 is there, and I need to add on top of it add of 3 to 5. Okay, and what is the output of it? 8. This is how you will call your curried function. Or the other way is you provide all the parameters at one shot, like the add of 3, 5, 4, 5, how many functions you have. The similar way you can call, and at one shot you can get your output, which is like the full curried function you are calling it with. Now you see the const A is a partial application of it. It returned your function. On top of that function, you have to pass a parameter which you are passing B equal to A of 5. Now 3 plus 5 it's gonna return, and the output B will yield you the final output, which is 8. Otherwise, I don't want to do it partial application and then do apply one more variable on it. I just want to say pass all the parameters for all the functions, and you're gonna do add of 3, 5. If you have few more functions taking multiple parameters, you can do at one shot, and it will give you the output for it. Okay, this is the currying concept, which is a major concept we'll be using extensively in your FP. And next concept as a function composition. We discussed a little bit when we are discussing about the benefits of our FP. Here, function composition is nothing but we are making sure while designing our functions to be a pure function, right? Why we want it to be pure? If it is a pure, and if it doesn't have any side effects on it, it will be easier to stitch together all functions to stitch together, and you will get one output of it. Let's say I have two functions, okay? Function 1 and a function 2. And the function 1 output, I want to pass it as an input to my function 2. That is called stitching, right? How you're going to compose your functions. One function output, I want it to be other functions input. And after doing all these things, you return me the final output. Okay. So in this example, you can see we have a function called double, which is a single arrow function. And what I'm going to do, I'm going to take one parameter and it will multiply with 2. And the other functions, what we have is square. Again, it will take single parameter and it's going to square it. Now, how I achieve the composition is like square of double of 5. What it's going to do? First, it's going to execute double of 5. It's going to call the double with the 5 parameter. What it does, and 5, our function says double is a 5 into 2. We got 10. That output, that function output, I'm going to apply with square function, square of 10. Now, what my square does is x into x, like 10 into 10. So output of square of double of 5 is first resolve your double of 5 and take the output, put it to a square. What is your output? It's 10 into 10, which is nothing but 100. That is called composition. And here in JavaScript, we have to achieve all these concepts like currying and the function compositions, we have readily available library, which is called Ramda. Ramda is a JavaScript inbuilt library where you can make use of all the functions, what it is providing for you. Everything is already curried, already you have that immutability and everything is achieved in these functions of Ramda, and you can make use of it. How you'll use it? For Ramda, all the functions of Ramda is available under global variable called R, and you can import that R and you can start using it. As an example, you can see here r.pluck. So what it does, it has an object. I want to take age from it. Okay. So in normal coding, you not have that flexibility, right? Here, you're gonna pluck age from your array of objects like 29, 27. It is giving you as an array. It gives you the values. Once you pluck if you say name, it's gonna pluck a Fred and Vilma. It gives you an output of array, which is already curried function for you. All the functions of Ramda is already curried, and you can start using those functions from the Ramda itself. So it will be a cleaner code for you. And for an example, you can see r.pipe. Somebody should go on mute. Yeah. So here you can see r.pipe. R.pipe is the same like how we define the composition, right? Function composition is achieved with the Ramda pipe, which is nothing but you have a group of functions in it. First math.power and then r.negate and then r.increment. Take the output of math.power and then r.negate and then put it to the r.inc. That will be your final output. And similar way, you have unique key, unique and keys. So many functions are there, and there is a documentation for Ramda, which we have given a link for the web reference, and you can explore more on it. Very interesting functions you can see over there. Yeah. Next slide. Yeah. Now we have a little bit knowledge about what is the currying and how the functions we are calling, how we can, if you just look at a glance of any source code, you will understand they did something on this. This is calling this function. If it is no parenthesis, it's just returning my function. If I'm calling with the parenthesis, it's going to execute my function like that, right? Now we'll see the code walkthrough. We have written a code in the way like you can compare both FP also and non-FP ways also, how you'll achieve the same goal. Then you will understand the difference. Yeah, over to you, Narmadha.
So let me start this. So initially we saw that our get store API, right? We said we'll want to test it for a valid store and an invalid store. And since we said the store details would be different for each client, we want to get the store detail, store IDs on the fly, and then pass that store ID, right? This way you're validating your store API. So the same thing when I'm trying to do it in a functional way, what all I can do, okay, what all things I can do further, okay. So I'll say have one method, find store with. This can accept a function, okay. You saw Sameena explaining how you can input functions to functions. And if you look at this, what I'm doing here is, say I have a function called random ID. This is just doing the same thing. It's getting a random store ID from your all the stores, all store API. Okay. Now, how I've implemented this function is, say during runtime, I'll decide whether I want to execute the function or use it as a variable. I'll use it as an object. So I'm going to check if this is if the type of this variable is a function, then you execute it. Okay. Otherwise, you directly store the value. Okay. That's why I'm able to send directly an object over here, or I'm able to send a function. Okay. So when I do this, I have when my use case is like I can keep changing any implementation here, right? Also, one more thing, what you'll do usually when you just hit an API, right? You'll get a response. Now you want to store that response and you want to send it back. So you have a defined return type, right? You always want to return either a body or a string or a status or the entire response, and then you decide what you want to do with it. Say you would have generic methods and then you would call this into that framework. That is one way of doing it. And FP way, what you can do is you can keep defining. Since you can return a function, I'll return a function called request and evaluate. And here I will decide what all I want to do. Say I want to just hit it. Say I want to handle errors. Say I want to decide how to execute it. I want to throw some random, throw some inbuilt exceptions. All this I'll keep carrying. So I'll keep sending it as a return of the first function, right? This way of coding helps us, achieve a lot of things without looking more into how we are doing it. All that we want to do is we want to check whether there is a store with this ID. And if it is not there, I want some kind of custom exceptions or I want different details. Okay. We'll look at another example. Okay. Let's say we looked at how we would code selecting the store in UI. Okay. What we saw was we'll always send different data in the test case, or we'll have different methods which do each of our functionality. 1 minute, let me just, screen is freezing a bit. So we said we'll take the client data, we'll get store names, then we'll pass client data to each function. Okay. Wherever required, I'll keep sending client data, I'll keep sending store names, I'll do this way. Okay. But say now we saw how higher order functions work, right? I can keep returning one function as part of another function. So in such a case, all that I want to do is select store. So when all that I want to do is select store, I don't want to call many functions. I don't want to call multiple times, right? So what I can do, I can have, I'll have one parent function, which I'll give my client data. And inside this, I'll have all the functions which are applicable to my store functionality. Okay. Since I'm telling you the client, based on the client, you're selecting a radio button is different, selecting your drop down is different. it's going to differ. You'll need multiple methods, right? So I'll keep all of this inside this one function, and I'll return whatever needs to be used in the test case. Okay. Say I'll return one or two functions. Uh, Let me explain it in a simpler way. So let's say this is my parent function. Okay. And inside this, I have multiple other functions. Say this is first. I have multiple functions like second, third, fourth. If you look at this, I have X and Y passed to first, right? So when I'm calling, so X and Y will be available throughout my function context. Okay. In JavaScript, it's always a functional context or a global execution context. Now, when I'm first saying, when I'm initializing call equal to first of 1, 2, the 1, 2 is available throughout this functional context. Okay. And what is returned here is fifth. I'm returning a function fifth. So right now, this call guy has this function. Okay. And then I'll choose to invoke that function. Then I'll choose to invoke fifth. Okay. Now, when I'm saying call dot fifth, then what happens? This executes. When I'm in executing fifth, here I will write execute second, third, fourth, etc. But to fifth, if you say I don't have to pass any parameter. If I pass it once, it's enough, right? It's going to be available throughout. So if I just execute this, when I call fifth, first what is going to get executed is second. And second of X, it's already having X, so it's going to print this. Then it's going to execute third. Then it's going to execute fourth. So for the sake of simplicity, I just kept calling the method, right? Invoking the method here. But instead, what you can end up doing is you can return another function within this function. So when you keep doing that, maybe it looks a little complex, but you're able to achieve a lot of implementations. You're getting rid of a lot of source code where you're saying store the return of fifth in one variable, store the return of fourth in another variable, then use that values to do different things, right? You're getting rid of all that, all those lines of code when you're directly returning functions and passing around functions. So the same thing we did here as well. When we want to select the store, all that I'm returning, I'm having one parent function, select store. To this guy, I will send the client data and I'll send the store names. That's it. Okay. With this, I will call select store value. Now, select store value, it will on its own execute the other functions, whatever is applicable, right? It needs to first find the type of drop down, or it needs to first find the type of the field. It'll do all of that. And then it'll need to get specific store names or any kind of logic, right? It would do all of that. But ideally in my test case, I just want to I just want to keep it simple. The functionality is just select the store. Okay. That's all I want to do. I don't want to keep a lot of functions and pass the same arguments again and again. Okay. This is one way of doing it. If you see further, there are a lot of benefits. Okay. Once you start using functions like this, you can, it is completely dependent on the developer, right? How intelligent you can make this work. So how intelligent you can make one guy return the other guy and implement other functionalities, right? So if we even when we look at APIs, right? When we started using FP, so what happened? We were able to get rid of a lot of redundancy. Now, for example, let's say I have an API like the get stores API, right? So let's say I'm just using this test API for this purpose. So let's say this guy, when it gets stored, I hope my screen is visible. So get stores, this guy is going to have a body something like this. He's going to have an store array array of objects. Okay. You're going to have like thousands of stores or whatever inside data. And that's going to have its own kind of contract. Okay. It's going to have its own contract. And now I want to do multiple functions on this, right? I want to do multiple test cases or use cases on this. Let's say one of the use case, I'll for showing an comparison, right? Let's say delete stores. Okay. For delete stores, what it's expecting is it's expecting an ID, and it's telling me my return value will give me the, let's say I'm deleting a store. If you, let's take a valid store ID. Valid store ID is 49. Now let's say I want to delete this guy. So when I'm deleting, I also have a response body of what store is deleted. Okay. Now, if I look now after deleting, I always want to add the store back. I don't want my test case to one day end up failing because all the stores are deleted, right? So when I want to add a store with the same details back, what is my post taking? What is my add store gonna take? If you see, it's definitely not gonna take ID. Okay, ID is created as it inserts, right? It's not gonna take ID. So from that object, let's say I don't need ID. I don't need updated time, created time, and all of that. I need only these input fields. Okay. So when you want to do something like this, you would try to write a Pojo for store body. Like you would try to write one Pojo class which has like all these fields, and then you would try to set data into that, and then you would pass it on, right? But instead, what I would do here in FP, right? Okay, the non-FP way I'll just show first. So let's say delete store, right? Now, for after deleting the store, I got the details after I got the response. Now I'm going to send it to my add store. And in my add store, I'll again say, I'll define an object. I will take each name and I'll create another object. And then I'll post this guy to the post pod, okay, to the post request. So instead of doing so much, right, in FP, I'll just use all those Ramda functions, all those inbuilt functions. What I can do is, let's say this is my add store, right? All I'm doing is take the response body, use a Ramda function, which is omit, okay? Similar to Ramda, you have other libraries also, okay? You have like underscore library, but the focus is it provides you such capability, right? It gives you the capability of it gives you functions which by default curry with the language is allowing you to do this. Okay, it's supporting such features. So my omit, what it does is it omits all these fields in this response board in this object, and it returns me an object. Okay, so I would just send this to my post request here. So such kind of benefits are present in FP. Also, like even when I want to pick, right, Sameena showed how you would just pick one ID from a response, right? So instead of always traversing through an entire JSON, like I don't want to traverse through the JSON, because I just want to get one value. If you see the get stores API also, say it's returning so many things. I don't want to traverse through this so much, right? I don't want to write functionality loops or iterations to traverse through this entire thing. I want to pick it up directly. And then parallelizable. So if you see, we keep writing await, right? So if you don't write await, no, it's not going to wait for this line to finish executing. So what happens, say you have some functions which is just going to say add numbers or some computational values, right? You need not, the execution doesn't have to wait for it. So in such a case, if the programming language supports that, your code is more parallelizable. Okay. And you get to choose, of course, you get to choose whether you want to wait for it, you don't want to wait for it, right? All such things you can do in FP. So for our use case, we're not saying this is the only solution. We're saying this is one of the solutions which we implemented to achieve to get rid of all those complexities. Okay. Let me now go back to our session. And so there are multiple other languages also which support functional programming, which allow you to program in this style. Say you have Haskell, Erlang and all, but you also have Scala, JavaScript and all who support both. They're going to support functional programming as well as object-oriented programming style, right? So you can choose how you want to code it. But once you're able to, what do you say, pass around functions, or you're going to take your functions as inputs and you're going to send them as outputs, it kind of becomes more beneficial in a lot of cases where you don't want to store the data and you don't want to, manipulate it all the time. You want to have a function which does that for you. Okay. Now, if we look at the cons of this, right, for starting, like for beginning, it would always be a little difficult, like until you understand the concepts and you code in this style for quite some time, it would be a little difficult for a beginner. But as you do it, you would be able to get the hang of it. And recursion, right? So you're not going to write for loops, okay? Like if, like suppose like Haskell and all, they're pure functional programming languages who wouldn't let you to write an iteration, okay? So in such cases, you would always have to think about it in a recursive way, how you're going to achieve the same thing in a recursive way. So writing that might be a little complex, but it has its own benefits, okay? And yeah, that's our talk. So that's it from our side today. Thank you for joining. Please feel free to post any questions.
So if anybody has any questions, you can raise your hand or you can post it in the Q&A.
I hope you learned something like some basics of functional programming with this session.
Yeah, we wanted to keep it very simple so that you have some takeaways from this.
As when we started, right, when we started looking into our source code, it was like magic for us. Like function is calling again the same function, and this function is there, but it is not getting called. How it is happening? That's like too much of debugging we did, and then we understand, and then we implemented in the test frameworks. That's how we got little hang of it, and that's how it continues. But yeah, functional programming is if you code it in way, it will be simple, but understanding it will be, starting with it will be difficult.
Thank you, Sameena. Thank you, Narmadha. So we have a poll. So it's a quick feedback. I'll just launch it. So if you can just answer the 3 questions, it would be very helpful.
Yeah, Anish Sheikh is asking, Java is also having a Lambda function. Yeah, Lambda function to support Java also is giving the functional support, functional programming style support using Lambda functions. Yes, right. In Ramda, how we have in JavaScript, how we have Ramda, the similar way Lambda is also there in Java. But most of the people will not use it functional way in Java.
Any other questions? Okay. Arun, shall we launch the poll?
Yes, bro.
Okay, I see another question. So from Anish, he asked, we can achieve FB functional programming using Java in using Lambda in Java, right? So that's the question.
Yes, yeah. Lambda is to achieve the functional way of writing the code.
Yeah. Any other question, folks?
All right then. Okay, so
We have one more question from Subramani Rajagopal.
okay. Yeah, can you take it up, Narmada or Sameena?
Yeah, Namita, you want to take it up?
Is there any challenge in debugging? No, you can debug it just the way you're debugging any object oriented also. You just keep the debug points and you can do it.
Yeah.
We have used IntelliJ, we have used VS Code, and both you can debug it in a normal fashion.
Yeah. Okay, that is answered. And we also, I've been using WebStorm in my project, and it's also very good when it comes to debugging. And Eclipse is a universal one. That's also a easier one to debug.
In any other question, folks?
Feel free to raise your hands.
Yeah. There is question from, have you used any design pattern? What to Narmadha and Sameena?
If it is a Scala based code base, whatever we have will follow the same design patterns what Java is applicable for it. And in JavaScript, usually like frameworks, whatever design pattern you'll follow, you can follow the same way, but the style of writing will be different. Design patterns throughout your FP style or the normal descriptive style will be same. Hope that answers your question.
Yeah.
You want to have a look at the code, I'm just pinging you the Git link, whatever we used.
Yeah, the Git link and the slide would be shared.
Yeah.
The participants. Yeah.
Yeah, and the whole session is recorded and it will be uploaded in the vodQA YouTube channel as well as in the Chennai vodQA GitHub page. People can look at back and also the past events from the vodQA, right? All the sessions are recorded. People can check on the YouTube channel and the GitHub vodQA page side. So you will find the recording for the different topics that we, and also thank you Narmada and Shamina and one and all who have joined. And I think I have really learned something from this event, that pure function, impure function, and closures. So
I
that
think so.
was really helpful. And yeah, so hope a participant also learn something from this event. And we will I will be sending the form to fill the feedback. There is poll already open in the Zoom. Participant can fill out, and also we'll be sharing the Google Sheet for feedback.
Yes, so I will just launch the poll. It has 3 questions. Okay, I have relaunched it. If you can answer it, I would give it a minute, after which I'll just end the poll. You'll be seeing it as a pop-up. All right then. I am going to end the poll. Thank you for over answered. And yeah, so we will be sharing a feedback form shortly. Okay. So before starting to fill the feedback, as I have already mentioned, for those who have missed the initial introduction, so not only vodka, ThoughtWorks as a company invests a lot of effort in strengthening the communities. So we have different events like a Geek Night for developers, and we have Converge for BAs, and not only thought workers, even other organization people can also participate and also be the speaker. And in all the public forums like Meetup or LinkedIn and our Vodka channel and the YouTube, we regularly update the upcoming events, and also we upload the link. We upload all the recordings of the previous ones and share all the details about it. So please follow it. So if you shortly, probably we are planning to have the next Vodka in another 2 months. So we will be sending out an email, and if you are interested to talk and if you're interested to participate and gain knowledge, you can do so. And I have shared all the required links in the chat, and we will also be mailing the same. If you have any questions, even you can just raise your hand. Right now I just sent a feedback form in the chat. Kindly take a minute to provide the feedback. Arun, do you want to add up anything?
No, Subha. Good.
Okay, so we have 5 minutes left. uh, So we thrive on feedback. So if you can just fill the feedback form, it would be helpful for us, and we would follow. I mean, we would take it very seriously in the upcoming sessions. Thank you everybody for joining. Thanks for taking your time. And we know it's a work day and you might be having other works and meetings. Thanks for taking your time, and we hope you learned something new and something useful from this session.
Thank you, folks.
Thanks, everyone.
Thanks, everyone.